Good afternoon, everyone, and thank you for joining our third webinar with John Rofrano. And for those of you who don't know who John is, he is our DevOps champion in IBM research on BlueHack. We tested this yesterday. He knows everything you could possibly know about BlueHack, so feel free to ask the questions. Just a quick note before we get started, if you look at the bottom of your screen, there is a Q&A icon. So if you do have any questions throughout the webinar, please feel free to add them in there, and we will try our best to answer these questions live. So make sure to use that Q&A or the chat icon at your pleasure. All right, take it away, John.
Okay, let me share my screen. Thank you. Yeah, share, boom, button, bing, bop, boop, charts. Good, yeah?
We can see it.
Okay. Welcome, BlueHack hackers, or Blue Hackers. So I'm going to take you through a little intro to Docker. I know we're a little short on time. I want to go through just conceptually a couple of charts on how Docker works, but most of this will be hands-on. And I think I'm going to go between charts and live because I've got some things on the charts that only happen the first time you use Docker, which I can't recreate live, so that'll be helpful for later. So yesterday we talked about Cloud Foundry, we talked about BlueHack and how it's a mixture, and Docker was one of the things in that mix. So what Docker is a really neat way of packaging up your application. I really think of it as packaging technology more than virtualization technology. And what it does is it takes your application and it gives you a process space and a network interface and a file system overlay so that only the things that you need, your application and its libraries are the things you have to package up with a container, and then they run anywhere, right? So I'm going to show you how that happens. What you're trying to avoid, is this kind of works on my machine stuff, right? Once you package it in a Docker container, it runs on any Docker host the same way it did on your laptop or in production. So that's kind of cool. So it gives you these nice portable environments. For the hackathon, you might be saying, well, when would I use Cloud Foundry? When would I use a Docker container? I would say Cloud Foundry is the cheapest, easiest. Go with that as a first pass. But sometimes you come up, and this happens in Python, probably happens in other languages, I'll come up with a library. Nice Python library, except it requires some compiled C, DLL, somewhere, some object code, some .so file or whatever. And you have to compile it from scratch. And at that point, you can't use Cloud Foundry. You don't have a compiler, you don't have an environment. So at that point, you go to a Docker file. You can compile these things in a Docker file. You can compile it outside of the Docker file, copy them into the Docker file. You can pretty much do anything you want. You can do in a VM in a Docker file. So if you need, including things like running C++ or C code, right? So then you would move to a Docker file because you can't do these things in Cloud Foundry. Here's an example here of using Python 3 and Python 2 and having them both running side by side in Docker files. The Docker files don't see each other, so they don't care what version of Python or what libraries they're using. So it helps with incompatibilities between libraries. All right, so it's going to save you a lot of time. Once you get your thing packaged in a Docker container, you can just push it up to BlueHack, and I'm going to show you how to do that. For the long term, Docker's not a VM. I wouldn't put monoliths in it, although you can run I've run Rails in it. Ruby on Rails in a Docker container. But you really want it for these small little microservices. Kind of explained this yesterday, how they're different. You've got these big VMs as opposed to these little tiny containers. I'm going to go quickly through this because I know we're short on time and I want to get to kind of the hands-on stuff. So, you want your containers to be stateless, lightweight. Again, you're going to try to do 12-factor. You want to use services. You don't want to move the services into the container. You want to use services externally. I'm going to show you again how to connect to an external database. At 12,000 feet, 20,000 feet, this is what's happening. You're going to say Docker run, and it's going to look in a local cache and say, do I have this image to go run a container from it? If not, it's going to go up to the Docker hub by default, unless you register some other registry. It'll go to Docker hub, try to find it in Docker hub. If it finds it, it'll pull it down, cache it locally, and then run your container. And then forevermore, they're going to run locally. You're going to see this behavior happen as we go through this on the command line. So that's kind of what's happening. There's a bunch of images up in Docker Hub. You can have images locally on your workstation, and then you can run them, build your own, pull them. We're gonna go through a couple of these. This is the important thing to understand. It's this layered file system. It's this copy on write file system. So you're going to get these layers built up where you only get the top layer is the layer that you write to. So you'll notice that when you're pulling these images, they come down as a set of layers. So you pull complete, and then you'll finally get the last layer. So if we look at, this is Ubuntu 15, there's all the layers that make up Ubuntu. It happens to have 4 layers. And then there's this thin read-write layer. So if you change a file in one of the lower layers, then it gets copied up to the top layer. It's copy on write. Once you write to it, it makes a copy of it. And then all of your stuff will be at the top layer that it will build for you. And then on the runtime, you got the thin read-write layer on top of it. Layers get reused. This is really cool. With VMs, you have a whole VM, and if you have another VM that's based off of Ubuntu, but it's a little different, you've got a whole Ubuntu. But Docker actually reuses these layers. That's going to be very important in building your Docker files quickly. So what's happening here is I'm pulling an Alpine Redis image, but I already had Alpine, the base OS, on my system. And so you can see it's using the same ID here. When I went to download Alpine, it says, I already have Alpine from the Redis image, and so I'm just going to reuse it and add the stuff that wasn't there. So it does that down at the layer level. So what can we do? Well, we can run middleware in Docker. We can run our app in Docker. We can use the existing images. I'll show you how to do that briefly. We can create our own images. Lots and lots of stuff you can do with it. We're going to go through all that. If you're going to use Docker, so based on whether you have a Mac or Windows or Linux, it's a little bit different. So I'm going to just go through that if when you start to actually use it. I don't expect you to follow me on the hands-on. I'm going to go quickly. 3 ways to use it. You got Docker for Mac if you got a Mac. That's what I would suggest for all Mac users. Docker Toolbox works on Mac and Windows. If you're Windows, you have to use the Toolbox. On the Mac, it's optional, but I wouldn't. I would just use Docker for Mac. And then you could always use Vagrant and VirtualBox to build a Linux environment or use real Linux and run Docker on top of that. So those are the 3 ways you can use it. Docker for Mac, you can Google on the web. I normally do this in a live session, so people are actually downloading these things as we speak. Runs on most modern Macs from 2010 on forward. You're not allowed to have anything as old as Yosemite and IBM, so everybody's probably got a Mac that can run Docker for Mac. Docker for Toolbox goes all the way back to Mountain Lion. For Windows, because Docker is Unix-based, you're going to have some kind of Unix environment, and so Docker Toolbox brings along VirtualBox to run the Docker engine in a Linux environment, or you can just use VirtualBox. Okay, so let's go forward through. These are all these options that you once you get it. Okay, so let's start by doing the hello world of Docker. So I'm gonna move over here. I'm gonna assume that you have Docker installed. You've either installed Docker for Mac or you've done it. This is a little VirtualBox VM I have here. And so I'm going to say Docker run hello-world. This is the ubiquitous hello world run in Docker. So watch what happens. So, and let me just give you a couple of commands. So I have Docker images, shows the images that are on this VM. I currently have Redis, which is a base image, and then Alpine, Alpine's a base OS image, and then Redis, which is built on Alpine. That's what's on my box right now. So I'm going to do Docker run hello-world. This is to test if Docker is installed correctly. So if you get all this nice mumbo-jumbo spewing down your screen, you know this thing worked. So let's go back and do a Docker images. So you can see now I've got another image. I've got this hello world image on the screen. If we scroll back a bit, you can see what was said. Get it right to the top here. So it was unable, the second line here, unable to find hello world latest, pulling from library / hello world. So it couldn't find it locally, went up to Docker Hub. Does Docker Hub have it? Yes, Docker Hub has it, pulls it down, and then runs it. So that's how that actually happened. Now, Docker PS will show me the program status of containers that are currently running. So if I do Docker PS, only my Redis Alpine image is running. So what happened to Hello World? Well, Hello World doesn't run as a daemon. It was just a script that runs once and it exits. When your program exits, Docker container exits, okay? So if you're running like a web service where it's continuously polling on a port, you're good to go. It's going to run as a daemon, and it's going to continually work. But as soon as your program exits, your container exits. So how do I see this exited container? I can say Docker ps-a, and that'll show me all the containers, running or not. And now you can see there's another one here called Hello World, and it was created about a minute ago, and it exited about a minute ago, right? Because it ran for like a nanosecond. So that's the Hello World image. Also notice that it has a name here. The name on this Redis image is Redis, because that's how I named it, but I didn't name Hello World. And so it created kind of a wacky name, right? Boring Goldberg is the name of this image. And if you don't name your containers, I'm sorry, the name of the container. If you don't name your containers, it will just pick a wacky name so that it doesn't conflict with containers you already have running. So now, how do I get rid of this container? I can say docker remove, docker rm, and then give it the name, Boring Goldberg, and then it removes that. Now if I do a docker ps all, I see I only have my Alpine image running. But my Alpine container running. But the image is still there. So if I do docker images, I still see the Hello World image. So to get rid of that, you use docker rmi, remove image. So docker rmi hello-world. That is going to delete the image from my computer. And you'll notice it untagged it. So these names are just tags. We'll talk more about that later when we push the BlueMix. And you can see that it deleted 2 layers. So it untagged 1 layer, and then it deleted 2 layers. So this is this layered file system I was talking about. And then if we go to Docker images, you can see I just have those 2 images running again. So Docker run will run an image. You can use Docker pull to pull it and not run it. If you just want to pull it and stage it. You can do Docker ps to see what's running, Docker ps-a to see things that are running and not running, Docker remove, Docker rm to remove a container that was running. You can also start and stop containers, and then Docker rmi, remove image, to remove an image that's in your image cache. Okay, so let's go back, and that's what these charts kind of go through, right? We've got the images, and we see the Hello World image, and we remove these unwanted images. So now let's start doing something a little bit more advanced, which is creating containers, right, from images that you might want to run. So I'm going to start with running Nginx. For those of you who don't know, Nginx is a reverse proxy HTTP server like Apache. I'm going to run Nginx without installing anything, right? This is like the cool thing about Docker, is that you could have all this software on your computer and not install any of it. So let's go do that. I'm going to do Docker run. Now, I want to run this, and Nginx is going to start listening to a port. And normally it's going to listen to port 80. But it's going to listen to port 80 in the container. And so what I want to do is I want to forward that port to my workstation so that I can play with it on my workstation. I don't want to forward it to 80 on my workstation because to forward ports less than 1024, you have to be root or admin, and it keeps prompting you for a password, and it's just annoying. So I just avoid that. So I'm going to say run this, and then -p for sharing a port. I want to map 8080 on my workstation to 80 inside the container. Okay, and then I have to tell it what image do I want to run. So I want to run Nginx : Alpine, because I love these Alpine images because they're really, really small. So you might be saying right about now, where is he getting this Nginx Alpine from? You know, where is he making this stuff up from? So let me bust that one right now. We'll go to a web browser, and I'm going to go to hub.docker.com. Hub.docker.com is where you can find all the Docker images. And so I'm going to do a search. So let's say I want Postgres. I do a search for Postgres, and here's the official Postgres image, and here's a whole bunch of images that other people have created based on that Postgres image. And when you click on it, it will give you a little bit of information about the image, right? All the Docker files, the versions. So it has these Alpine versions. I think I had mentioned yesterday, Alpine, it's built on BusyBox. It's a really tiny Linux. In fact, if we go look at, let me just cut this. I don't have to type it again. Oops. And let's look at, oh, I can just scroll back. So this Alpine image is 4 megabytes. It's not gigabytes, it's megabytes, right? So Ubuntu is 188 megabytes. So if you're going to deploy your app on Ubuntu, 188 megabytes is the cost of doing business, and then your app goes on top of it. And then there's all sorts of stuff running in Ubuntu that can be attacked. Large attack surface, lots of daemons running you don't even care about, which is why I use Alpine, right? Because it's very small, it's the kernel and very little else. And then it only takes up 4 megabytes, so it's my app on top of that. As you can see, Redis is only 19 megabytes for the whole image. Okay, so let's go back. So usually what'll happen, it'll tell you a little bit about the image, it'll tell you how to use it, it'll give you some Docker run commands, right? So any of these images you want to learn how to use and deploy, you just click on them to get those Docker run commands. So let me go back and put in Nginx. This is how I found out about Nginx. Nginx. I hit Nginx. I like to stick with the official images. For work within IBM, once you download these images, you should, of course, scan them for viruses and that kind of stuff before you proliferate them. But if you're just playing around trying to see what works, feel free to download them. And then when you find one you like, you can do a scan on it. So this is telling me all of the different Docker files. So I've got an Alpine one here. That's the one that I chose. And then it gives some really good information about how to run it. It's telling me one default way to run it, say Docker run, give it a name so it doesn't get some wacky name, share a volume, which we're going to do in a second, and then run it as a daemon, -d, and Nginx, and that'll run the default Nginx image. And then it's going to show you how to create a Docker file by copying from Nginx and copying files in a directory. So we're going to do all that. Let's just run it first. So I'm going to say Docker run. I'm not going to run it as a daemon. I'm just going to run it in the foreground. It doesn't exist on my computer, and so the first thing it does is it pulls it down, and it brings down that image. Once the pull is complete, it's now running Nginx in the background. So let me go to my web browser, and I'll go to another tab here. And I'm going to say localhost, and this time 8080, right? That's what I mapped it to, and there's Nginx running from a Docker container on my laptop. If you don't believe me, well, here's the log file to prove it, spewing down the screen. If I do Control-C to stop it, and then go over and refresh the screen, you'll see that it can't talk anymore, right? So that was running Nginx, but it was running the default Nginx, right, with whatever's in the container, and of course there's nothing. You want your website in the container. So how do I get stuff into the container, or how do I share stuff? So one thing you can do is you can share a file system. So I'm going to clear the screen here. I'm just working in a home directory here on a Vagrant VirtualBox, and I'm going to create. So I'm going to do an echo, echo, and just hello Docker, redirect it to index.html. Right, so now I've got an index.html file that says hello Docker. I have this command on the side here so I don't have to type all this stuff, so I'm just going to cut and paste it to make it easy on myself. So what am I doing? I'm telling Docker to run. I did -d as a daemon. I want to port forward, so I want to forward 8080. Actually, I want to forward 80 from within, it's backwards, 80 from within my container to 8080 on my host. And then I've got this -v, which says map a volume. How do I know what that volume is? Well, I went to the Docker file, and it told me, right? It said it in here. If you want to map a volume, user share nginx HTML is a volume that's shared outside of this container. So if you map a volume to it, it will read your volume instead of the volume that's in the container. So that's kind of the magic of running the container stateless. No data, no state in the container. Keep your data separate. So you can kill the container, bring it back up, and your data is still preserved. So that's what I'm going to do here. I showed you that I'm in my home Vagrant folder. Sorry, a little slip of this cursor there. I'm in my home vagrant folder, so I'm going to map home vagrant, a colon, and then where's the share inside the container. I'm just going to load it read only. And then what is the image that I want to create this container from? And it's Nginx Alpine. So now I'm going to run that. Done. So it's running. This time it's running as a daemon in the background. If I do docker ps, there it is. Nginx is now running, right, as a daemon in the background. If you look at the ports, you can see that port 80, right, is forwarded to 80 inside the container. On my Redis one here, I'm using the same Redis port, but in Nginx, I'm using a different port. So you can see that that port is forwarded. And now, if I go back to, if I go back to my browser and I refresh from localhost, hello Docker. Okay, so what just happened there, right? I ran a container. I told the container to map an internal volume that was inside the container to an external volume that was on my laptop. And now it's serving up what's in my laptop. So think about that, right? You're developing this website and you've got, Nginx, or you've got Apache, or you got Tomcat, or whatever, running in a Docker container, mapping this volume to your current working directory. I'm changing files, saving them, refreshing my browser, and I'm seeing the changes come through because I've got Docker running, listening on that volume, showing me all the changes as I go back and refresh the browsers. Very cool, very powerful way to work. The other thing you can do is you can package everything up into the Docker file. So sometimes you want the Docker file to be all-inclusive, and you just send people a new version of the container or of the image, and then they create their own container from it. So let's do that. I'm going to make a directory called content, and I'm going to move my index.html into my content folder. Right. So now I've got a content folder, and in the content folder, I've got this index.html. Let me go back up one. Okay. So now what I want to do is I want to place that contents inside the image so it shows up in the container. For this, I need to make a Docker file. And this is what you're probably going to be doing the most, is creating Docker files. So let's make our first Docker file. A Docker file is the infrastructure as code that creates an image from which you can instantiate a container. I'm just going to use VI here. And Docker file is always called Docker file. It's always a capital D. You can build from Docker files by overriding that name, but that is a default name that'll be used. So that's the one I stick with. So the first thing you want to say in a Docker file is, where is this coming from? Everything has to be from something else. Somebody makes a base image somewhere, and then everyone else just derives from it. So I like to keep my, my commands in uppercase. I don't think they have to be, but I like all the official keywords in uppercase so I can read it better. So I'm going to say this is from Nginx Alpine. So you notice this format where I've got a name, a colon, and another name. So the default would be, if I just said Nginx, it would say Nginx colon latest. And whatever the latest version is, that's what I would get. So in some cases where you just want to refresh from the latest, you wouldn't get Alpine. You'd probably get something based on, I don't know, BSD or Ubuntu or something else. But you just say Nginx, you get the latest Nginx build that's out there. You can probably say things like Nginx colon and maybe a version, right? Again, you have to, you go look at the, sorry, I keep switching back and getting confused because this is multiple screens. You go here and see there's a 1.3.2 and there's a 1.2. So you can put colon, 1.2, 12.0, whatever, and then you'll get that version, right? So, but we're going to start from this Alpine. And the next command I'm just going to say is copy. That's a keyword. And I want to copy content, which is that folder, that content folder. And where do you think I want to copy it to? I want to copy it to user share Nginx HTML, which is where Nginx is going to be looking for things inside the container, right? And that's it. That's the entirety of my Docker file. Good if I hit escape here. Okay, so now I've got this Docker file, and let's look at what's running because I forget. Docker PS. So Nginx is still running. So I want to say Docker stop, and I want to give it. So this time it was called Sad Banash because I didn't give it a name. So whoops, it was wrong. Hang on. Docker stop. Now I can either use this name or I can use the container ID. So this time I'm going to use the container ID. You can do it both ways. So I'm going to say Docker stop. That will stop it. If I start another one, it'll just start another one up. I don't have to remove it unless I want to clear up space. And if I want to remove it, I would just do a Docker RM on that, and that would remove the container as well. Okay, so let's start this other one up. So I'm going to say Docker run. I'm not going to run it as a daemon, so I don't have to keep stopping it. Docker run, we're going to forward the ports. So 8080 goes to 80. Oh, actually, I want to build it first. Okay, so if I do this, 8080 to 80, and then do Nginx :Alpine. So that's going to run. Oh, nice if I spell Nginx correctly. Nginx Al. Oh, I didn't spell Alpine correctly. Okay. So it told me, couldn't find that. So now it's running. Let's go back over and refresh. So that's the regular Nginx page, right? But now I want to build a container that has my stuff in it. So I'm going to use Docker build to do that. Let me clear the screen for you here. So I've got my Docker file. There's my Docker file. It says from that Nginx Alpine, copy the content folder to user share Nginx HTML. And when I look at what's in content, index HTML is in there. So that's my website. So now I want to build this up as a package. I'm going to say Docker build. And then I need to tag it. Remember I said there were tags? So if we look at it, if I say Docker images, these are just tags on the side here. Nginx, Redis, Alpine. The whole thing is considered a tag. I know, even though I know the last part officially says tag. And you'll see why in a minute when we push into BlueMix. So I can have this image tagged multiple times, the same image, and give them different names. So what I'm going to do is I'm going to say Docker build, and I'm going to tag it with a new name. So I'm going to call it my Nginx for lack of creativity. And now I have to tell it where do you want to build from, and I just put a dot, current directory. Right? So if I wanted to build from a subdirectory, I point it to that subdirectory. I'm pointing it to the Docker file. All right? I'm pointing it to the Docker file. The Docker file is in my current directory, so I say build, Docker build, tag it as my Nginx, and then build from the current directory. So I'm going to hit enter. I'm going to watch that build. It's done. And so why is it done? Why was it done so quickly? Well, Nginx was already in my cache, right? I already had that in my images cache. So from Nginx, it's just a matter of saying, oh, use those layers, right? And then create a new layer, which is copy content. And then it successfully tagged it as Nginx :latest. So now if we look at images, I now have an Nginx latest because I didn't put a colon after my Nginx. So I have Nginx latest. You can see that it's a different image. So let's go run that now. So we're going to do a Docker run. Just going to up arrow a few times here. And instead of doing Nginx, I'm going to say my Nginx. So now it's running my version. And if I go over and refresh, there's my hello Docker again, coming from within my container, right? So I've got my app, my website, my whatever, deployed in a container by using copy. There's also an add command, and I'll show you how to use that as well. I've copied this into the container, and actually I've copied it into the image. I'm sorry, I keep confusing images and containers, I realize that. I copied it into the image, then I create a container from the image, right? So now the image is something you could push back to the Docker registry if you wanted it to be public. We're going to push it to the BlueMix registry because we want to use it in BlueMix, and I'm going to show you that in a minute. But you've got this image. Now, other people can pull from that image, instantiate containers, and then they will have your application running in their own little container. And that container will run the same way on your laptop as it does in production or in Bluemix, or in a Kubernetes cluster on Google, or on Amazon, or in Azure, or wherever you want to run these Docker containers. So that's another difference. When do I use Cloud Foundry? When do I use Docker? Cloud Foundry only runs in Cloud Foundry Cloud. So IBM's got one, Pivotal's got one, Cloud.gov is a Cloud Foundry cloud, but Amazon is not, and Azure is not. So containers run everywhere. That's another great thing about packaging your stuff up in containers. All right, so I'm going to Control C to stop this. And now we're going to go on to something a little bit more exciting, and that is taking an application and pushing it to Bluemix. Now, the reason I want to go through this, sorry I'm quickly going through these, is because there is something that happens the first time you push to Bluemix, and I want to get to it. So yeah, let's talk about a more advanced Docker file now. So I've cloned my repo, and I've created this more advanced Docker file. It says here I want to go from Alpine 3.3, so this time I didn't say Alpine latest. I used to say Alpine latest, and I teach down at NYU, and right before class I was testing things, and stuff broke, because there was something about 3.4 that broke my code, and I learned to put 3.3. So there's a double-edged sword. Always get me the latest, and then stuff could break. So this time I say Alpine 3.3. Maintainer has been deprecated, but this is an older file, so the maintainer's like, who do I go yell at when this thing doesn't work? And then your commands. So any command you want to run in that container. Now, I'm using Alpine, and APK is the package manager in Alpine. It's like apt-get in Ubuntu, or yum in Red Hat, or CentOS. So I'm saying update these packages, Python and PyPip, and that's it. So I really just have like Alpine, the kernel, and a little bit more, and then just Python and pip, and then I'm going to go install packages. I've set an environment variable here with the env. So that's saying set an environment variable called 5000. You'll notice how my code pull things out of the environment. So if nobody overrides this, it's going to pull 5000 out of the environment, and then I expose it as a port. This is a Python Flask application. Flask talks on 5000 by default. So I expose that port so that I can talk outside the container. Then I create a working directory for my app, and I call it app. Could have called it foo, could have called it anything. Lots of people just use app. I just follow the conventions. Then I add my requirements.txt file. If you remember from Python, so let's go over to the code here. We've got this requirements.txt file. Let me make this bigger for you, right? So these are all the Python libraries that I need to make my app work. I need Flask, I need Redis, I've got a bunch of stuff, my nose tests and whatnot. So those are the libraries that will be my dependencies that will be installed. So what I'm doing here is saying, actually I could stay on this screen and show it to you, it might be bigger, because it's the same file. Docker file, oh, sorry. Here it is. All right. Alpine 3.3. This one's a little bit cleaner. I learned the no cache command. So before I was clearing out the cache in a rather unorthodox way of removing the cache. But this is doing it a little bit more eloquently. I expose port 5000. Then I am adding this requirements file, and then I'm doing a pip install on it. Then in my case here, I'm adding the static folder up here, and then I'm adding service.py. Now, you can say add dot, and it will add everything in your directory. If you do an add dot, I would seriously suggest that you have a Docker ignore file that says ignore these, don't put all this stuff in my Docker file. So I'm sorry, that's my git ignore, Docker ignore file. Right? I don't want my Git repo in there. I don't want my metadata from Vagrant. Don't need the Docker file and the Vagrant file in there. Lots of stuff I don't need. So the Docker file, the .docker file says, don't put this stuff in my Docker file if I say dot. But I rarely say dot. I usually name the files that I want, so there's no surprises. Let me go back to this Docker file then. So then I add that, and then I have the final thing on the bottom, which is the command. that I want to run it, which is python service.py, right? So that's the command to run my daemon in this Docker container. Now, why do you think I took requirements out of the other adds down here and put it up above? I could have just said add dot. I could have added requirements and then run pip install. But remember that it's a layered file system, and the layers get cached. And it's a little bit upside down because the top of the Docker file is the bottom of the file system, right? When I say from Alpine, that's the lowest layer. Then maintainer, then add, apt, add all these things, apt-get, yum install, whatever, all this stuff, right? Expose a port. So you want the things that change the most at the bottom of your Docker file, and the things that change less often up at the top, because the layers get cached. So and if you're in a hackathon and time is of the essence, you don't want to spend a lot of time with your Docker file having to build. So what I'm doing here is saying, just add the requirements file and then run pip install. That creates a layer of all of my dependencies that don't change very often. Then the thing that changes a lot is my code, right? I put my static next, and then I put my actual code after that, so that while I'm changing service.py and I say build a new image, it's going to go like that. Because it's going to go cache, 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 got a hit, and then it starts building from there. And it then validates the cache from wherever the hit is on down. So if you put something that changes often at the top, even though things don't change often underneath, they're all going to get invalidated. It's going to rebuild the cache from where it gets the first hit. So I try to keep the things that change a lot down at the bottom. Okay, so that's what's happening here in this particular Docker file. So what we're going to do now is go build this thing for BlueMix. So let me go back to the charts and make sure I didn't forget to tell you anything. Okay, so the next thing we're going to do is we're going to go build this. So I have an environment here. This is my Docker lab, and this is the code that we saw in the editor. So now I'm going to build this. Now I'm out of that VM. The VM was the black screen. The screen's kind of a AIX green, for those who remember AIX, a deep green, and I've got different images. So if I go over to my VM and I say Docker images, there's only the few images that I had in there. But this is my laptop because I'm using Docker for Mac. So so now when I say Docker images, you're going to see a lot more images. I didn't want you to get confused. These are two different environments. Docker images, boom. These are all, make this smaller so you can see them a little better. These are all the images that I have on my laptop. Got Jenkins and OpenJDK and MariaDB and all sorts of stuff on there. Ubuntu images for all sorts of testing that I do. But there is no lab Docker, because we're going to go build that. So again, I'm going to say Docker build. I'm going to tag it as lab-docker. That's the name I want it to have. And then I'm going to hit period because I want it to build from this current directory. And I hit enter, and boom, it went pretty fast. Of course, now it's doing the pip install. So it's installing all of the Python packages, telling me that my pip is old and I should upgrade it. But you can see the layers being built here. If we scroll back, if we scroll back to the top, right? We can see all the steps happening from Alpine, maintainer. Notice maintainer using cache, run APK using cache. Where is it getting that cache from? Well, I build all my containers this way. This is kind of my stock Docker file for all my containers, and I change the stuff at the bottom. So a lot of these things are always in my cache. Remember I said Docker, it doesn't take entire like VMs like VMware does. It takes individual layers and it stacks them up and caches them. So I got cache hits. I got cache hits all the way down to my requirements file because it was a different requirements file for this particular project. So all that stuff got cached. I didn't have to wait for Python and all that stuff to get installed, but I did have to wait for everything underneath it. So now let me do a Docker images. And you can see up at the top, usually your latest ones are at the top. There is a lab Docker up here at the top. It was created 53 seconds ago, right? So that's my Docker, my lab Docker image. Okay, so how do I get this to BlueMix? Let's see what charts I have to guide you along the way. Well, actually, Leah, let's run this locally first, see what's happening. So I'm going to say, oh, wrong environment. Docker run. Let me make this bigger, and I realize I'm going between you guys seeing everything on the screen and the fonts being big enough. So we're going to go Docker run. I can do a -- remove, which will remove it after it's finished running, so I don't accumulate them and have to go remove them later. So -- remove is kind of cool. -- remove does not work with daemon. You can't do a -d and a -- arm at the same time, so they're kind of mutually exclusive. So I'm going to say run and remove. Now this time I'm going to forward port 5,000 to 5,000, right? Because inside the container, my Python app is listening on 5,000, and I want to access it from 5,000 on my laptop. So 5,000, 5,000. What else do I need to tell it? I think that's it. Just the name of the image to build this container from. Oh, I could give it a name. So I could do -- name, and I can say demo. And then I have to give it the name of what I want, the image that I want to use. So it's lab Docker. Okay. So what it's going to do is it's going to look for lab Docker. It's going to find it locally because I just built it. It doesn't have to go to Docker Hub. It's going to run it on port 5,000, and this is going to run in the foreground, right? Okay, so you already noticed a little error here, right? It couldn't ping Redis, and I kind of showed you the code that I had last time that I put in almost all of my services, and this one is connect to Redis. So again, I'm going to run this in Bluemix. I know I'm going to run it in Bluemix. I know VCAP services. We learned yesterday. VCAP services is where we get all of our services from Bluemix out of the environment. So if that's in the environment, then I want to go pull the Redis information from the environment. Otherwise, then I do a ping to see if there's a Redis service running locally. And then if there's not, I default to 127.0.0.1 and assume that it is running local on my computer and not somewhere else on a Docker container called Redis. So that's what it's doing. And let's go hit this thing and see what it does. All right, so localhost 5,000 this time. Not. It says it's running, but it's not communicating. I don't know why that one says localhost 8080. Let me start a new thing here. Localhost 5,000. There we go. So that is the app running. If we go, you can see that we had a couple of gets on the service here. This is the static HTML page that it's serving up, Python Flask hit counter and Docker, and that's my hit counter running. And now if I click on counter, it'll link me to the API. So what happened? Internal server error. Let's go check that out. Woo, lots of stuff scrolling up the screen, and it's got an exception, right? And the exception says connection refused. So it was trying to connect. You can see here, connection error 111, right? On 127.0.0.1 colon 6379, which is the Redis port, says can't find Redis. That's because I don't have Redis running on my local host. So what I'm going to do is fix that. So remember I'd mentioned yesterday, I have a bunch of machines that are kind of quiesced in the background, so I don't have to give these long commands. I can just start and stop them when I need it. And Alpine Redis is one of the ones in my list. So I'm just going to say Docker start Redis. So now I've got Redis running. If I look at Docker PS, I can see that Redis is running. If I go back and start my service and run it again, and go back to my web browser, and I'm going to refresh that. Let me go back one. So here we are, and then I'm going to hit it again. Still an error. What happened there? It used to work. When I was running this thing outside of the container, I could run it, and it would talk to Redis. Well, as I explained yesterday, what's happening is when you run your code locally, and you run a database, let's say like Redis, in a Docker container, and you export the port, it looks like it's running on the local host. And if you're running on localhost, you're good to go and you find it. But when I package my code up in a Docker container, now I'm not running on localhost. I'm running in a protected environment. And so I can't see localhost, and I certainly can't see the Redis container. So I've got to link one container to the other. So let's do that. This time, you need to stop. So this time, remember, let me do this. Docker PS, the name of the image is Redis, because when I instantiated it, I did a -- name Redis. I gave it the name Redis. So now when I run it, what I'm going to say is -- link Redis. What this is going to do is when Docker runs this container, it's the Docker engine. It knows everything that's running. It's going to go find the IP address that Redis is running on. It's going to inject it into the container in the host file and call it Redis, like a little mini DNS. So I can just address this thing as Redis, and the host file will resolve it to the IP address of the Redis container, and that will get Redis running. So now when I run it, and I go back, let's go back, and let me go back once more. All right, so now I've got this, and I hit counter, I get a counter. Counter 1, and when I refresh it, I get counter 2. When I refresh it, I'll get counter 3, because all it is still a hit counter. So it's now talking to Redis. Okay. Let's go back here, and let's get this doing the same thing up in Bluemix. Okay. Took you through that. We did the link. We got it working. Okay, so deploying it to Bluemix. So let me go over to Bluemix and show this to you. There's one thing you're going to need to do. You're going to need to download and install, and this is where I thought you're going to need to download and install the Cloud Foundry CLI, because there's no way to get the containers up there except to use the CLI. So you have to use that command line interface. So you'll need the Cloud Foundry CLI, and you'll need the container plugin, right? The IC IBM Containers plugin. So I thought I had installed stuff here. It's not here. Okay, so let me take you through this live. All right, so what we want to do, let's get a few more Control-Cs to get out of that. Okay, now I'm out of that. All right, I have already logged into Cloud Foundry with the CF command, and then I have this, the IBM Cloud Container plugin already installed. So I can now make these commands CFIC, Cloud Foundry, IBM Cloud, and then do commands. They're the same commands as Docker, except with CFIC. So let me show you. I can say Docker images, and those are all the images that are locally on my computer. I can say CFIC images. Takes a little bit longer. Those are the images that are available to me in Bluemix. Some of them have my name on them, because that's my namespace in Bluemix is Rofrano. And then some of them don't. So the ones that don't are the ones that are provided by Bluemix. And then these here that say Rofrano, I have Ubuntu and Postgres and Alpine and Redis and Mongo. So I'm going to add my lab Docker to that. Before I do, let's go over to Bluemix. So I'm at bluemix.net. I do a login. Again, it probably doesn't have my credentials. So this time, so you put in your IBM ID, and then it tells you got to do the W3 ID thing, because it's doing single sign-on. It's going to prompt you for your W3 ID. Actually, that was in the cache. Okay. So here are all my apps. You saw these yesterday. Here's a container group that I have running. And then here's a set of services. Now, you notice next to service, there's create a service, and next to app, there's create an app, and next to containers group, there isn't create a container. Don't know why. But the way to get in it is to go over to the menu here and select containers. So that'll bring us to the 2 container options. One container option is Kubernetes. It's a brand new option. I'm not going to show you Kubernetes today. That would be another hour to explain Kubernetes to you. and that's I think it's way more entailed for a hackathon. I think the quickest way to get in and out of this thing is using the older container service. So I'm not going to create a Kubernetes cluster. I'm going to click on containers on the left here, and now I get to create a container button. So here's create a container, and it shows me all the containers that are available. It's just still spinning here. So here's my Alpine, my Mongo, my Postgres, my Ubuntu, but not my lab-docker, because I haven't pushed that one up there yet. So let's do that now. So I need to give it a name that matches the others, and I'll show you that in a second. So here is Docker images, and lab.docker is up at the top. Sorry, scroll through lab.docker. So what I'm going to say is I'm going to tag it. I'm going to say Docker tag, and then what do I want to tag? I want to tab lab-docker as registry.ng.bluemix.net, got it for my other ones, / my organization name, or really my namespace in the registry, which I made to be Rofrano, and then lab-docker. What this is going to do, Bluemix Docker works on a very simple principle. You can't have any dots in the name. If you have a dot in the name, it assumes the name is a URL, and it tries to go find a registry with that name. So dots are not allowed in the name unless it's part of the URL. So what's happening here, it says, all right, you want to tab lab docker, but you want to give it some registry name / something else. And I hit enter, and there we go. This time I'm going to do Docker images, and I'm just going to grep lab-docker just to make the screen cleaner. So now I have lab docker, and then I have my registry ng bluemix lab docker. Notice they're the same image. The image ID is the same. Remember I said you can tag these things multiple times, call them multiple things. So the image ID is the same. It is the exact same image. All I did was give it this tag so that I could push it to Bluemix. So now I say docker push, and I want to give it the name of what I want to push, and that's registry index Bluemix.net Rofrano lab docker. I'm going to hit enter. I tested this and it worked before. CFIC init. So once you do your CF login, so this authentication here is failing, but I believe this worked before. Docker push. No, so we're not going to be able to push it. Okay. There's also a bx command, a Bluemix command, and I was going to try to stay away from that, but I think the only way I'm going to get this thing up there is with a Bluemix command, unfortunately. And I believe for Bluemix, it's bx, and then it's the container registry. I think it's the same thing, push. I'm not sure why this is not authorizing. Okay, bx, I think it's CR, yeah. Bx similar, bx, when in doubt, image list, image inspect, list. Image inspect. I don't see an image add. So bxcr images. So this is a different view. Yeah, I didn't want to use this because I've got multiple accounts, and this one is sensitive to the multiple accounts. So it's got image list, images, image remove, image inspect. I don't see one to push an image. I think the other one was container bx. There was CS, bxcs, container service. Yeah, and so the container service is the Kubernetes stuff, which is why I kept away from this. So I don't know why this is not authenticating, because I did authenticate. I did make sure I could push it before. So I can't show you that image. Okay, we'll have to figure out why this wasn't working. So had it worked, the image would have shown up over here. So let me just deploy another container here just to show you how you would go through and do the deployment. That's very, very unfortunate. I apologize, but I did run through this an hour ago, and it worked. Okay, so when you create a container, you can create a single container or a container group. So this is a scalable container group. So what I'm going to do here is create a scalable group, so that'll allow me to have multiple multiple instances running at the same time. It also gives me a name, a host name. So if I click on a single one, you'll notice you can assign an IP address, but then it's got to have some 1.68. Some IP address. But if you use a scalable group, it'll allow you to assign it a host name. So let me give it a host name, and I'm going to call it alpine.group. Notice that's going to be the same name down here, alpinegroup.mybluemix.net. Had this been the real lab that I wanted it to be, I would have said that I wanted to run on port 5000, right? Because that's what my container was running on. And then in these advanced options is where I would link anything else that I want to run on it. So there's this little divot up here that you have to use to open these. And this is where you could attach volumes to your container. So if you needed a volume to put data on, you could attach it to your container. It's also where you can do service binding. So now I can select a service. So if I want to bind that Redis Cloud service, I would select it from here, but you're not done yet. Spend a whole afternoon selecting it and hitting create. Doesn't work. Then you have to click this add button so it comes over here, because you can add multiple services, right? So you select the service, you click add, it shows up here, and then when I say create, it's going to go off and create that service. It should just take a second before it gives me the screen back. Okay, so it's defaults to 3 instances, defaults to 256 per instance. You could change that with, you could do command line deploys from the CLI, and you can control all of that stuff. The thing I wanted to show you though, so now it's running on a route called alpine-group.mybluemix.net. So if this was my lab, right, this is my code that I wanted to push out there, that would be the URL that I would get it from. If I hit on that, nothing's going to happen because there's nothing running. There's no web server running at that address. But I also wanted to show you, a little error message here about scaling groups, that if I click on connections, it's now connected to the Redis Cloud service, right? So when this thing is deployed, it connected it to Redis Cloud. It injected VCAP services into the environment so that my container can see it. One thing I didn't show you yesterday was monitor and logging for Cloud Foundry, but there's a monitor and logging tab where you can go here and you can extract your monitor. You can extract your logs to see what's going on in your log files. You can see your CPU utilization, your memory utilization, etc., and your network I/O in bytes. That's taking a while to come up. We're at the bottom of the hour here, I think.
Yes. John, we actually have a question as well.
Okay.
The question is, would the bxcr login command let you authenticate?
Yeah, it probably would. And let me try that. I think that's a helpful hint from the audience. Let's go try it. So as you can see, I'm using API keys, so I don't have to worry about using passwords. And I will have to delete that API key after this demo, so don't bother copying it down. Okay, so in my dev space, cool. New version, no, I don't want the new version. I'm doing a demo. Dude, okay. All right, so now my BX, yeah, but push still wasn't a command here. So let me go look at my commands here. So those, I've only used the BX stuff with Kubernetes clusters. right? Because I've been using the CS stuff all along. So this is still going to tell me that push is not. I don't think the BX would have authenticated me with the others. Let's try that again, just in case. But I think this CF and the BX are different. So see how I see push, and I was pushing, and I got to do images again. I can't remember the name. Docker images grep lab dash docker. Okay, I want this image name. It's up, you guys can see it. CFIC push image name. Docker push image name to push image. Okay, we'll try that. I'm not beyond taking advice. Docker push. No, it's a different authentication, and I don't know if they've deprecated one in favor of the other, but I did try this, right? I did do this before, and it did work. So at any rate, so let me go back through these charts just to show you. Yeah, so what you would do is this CF login and then CFIC login, and just what we did. Docker build the image and tag it, and then tag it as the BlueMix image, and then push it to the registry, and then you could actually run it from the command line if you want to. So this is a login. This is what I should have seen had the authentication not fail. It would have given me that yellow text that I could copy and paste into environment variables. This is the one I wanted to show you. The first time you try this, it's not going to work. It's going to give you this namespace error, right? See, retrieving client certificates for IBM containers, blah, 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 something about a namespace. You've got to do a CFIC namespace set and then give it a namespace. I gave it my last name. You can give it whatever you want. For my NYU account that I use with my class, I set the namespace to NY_edu, just so it was different, because I couldn't do Rofrano again because there's only one BlueMix, right? So, okay, so we would have had an image in BlueMix. When we went to the catalog, we could have selected Redis and added it. I already had one in my environment, which you guys know from yesterday. But then we do the create the container. Again, scalable. I set lab Docker. Oh, here's where you set the memory. So I kind of skipped over that. How many instances? It was right on that page. Then you've got the name that you want it to be, whatever.mybluemix.net. You select your port. You go over it to these little advanced options, and you scroll down to Redis. You click add, and then you hit create. And that's kind of where we are now. We can see the thing running. And then if we go to the overview, you'll see your route on the side, which we already saw. And then when you hit the hit counter, it should be working, right? That was kind of the whole thing. You could deploy these from the CLI. I have these commands in here. I can make this PDF available to you to deploy from the CLI, but it's just as easy to deploy from just from the UI. Makes it much easier. Okay, I guess we need to stop. We're well over the time. There's a lot of stuff to know. Sorry I didn't get to creating a tool chain, but it's very different than the tool chain we created yesterday. Maybe we can go through that one again. But having a tool chain makes it very easy to have multiple people working on a project and then redeploying automatically. You want to stop at this point?
Yeah, I think we are 10 minutes past our time, but just wanted to open it up to the group and ask if there were any more questions. Feel free to use the Q&A box icon that's at the bottom of your screen to ask any questions. I know that it was after our call yesterday, John, we did have a couple of interns reach out asking, for your contact info because they had more questions. So if you're open to it, would it be all right if they reached out to you?
What they should do, yes, absolutely reach out to me. But what they should do is they should post on Slack to the Research DevOps channel.
That's a great idea.
That's where all the DevOps champions hang. I'm just one of many DevOps champions. So if I can't get to you, someone else will. But and then the whole community can see the answers and benefit from them. So I'd rather than try to solve these one-on-one, just post to Research DevOps on Slack, and I'd be happy to answer any questions. You could also reach out to me on Slack if you don't want to, if you think it's a big question. But so feel free to reach directly out to me on Slack, but you can always find me on Slack.
All right, excellent. Also, to all the interns, we do have Sergio posted out the link to the box folders that actually has a recording or the copy of these recordings that are available to you at all times. So please make sure to check your chat box. It does have the link to the chat to the box folders in there. All right. Again, if there are no other questions, I want to thank John for his time and for being flexible. And this was very informative. So
thank you.
Thank you all again, and have a great day.
Okay.